Hello everyone. This will be the last video that I make, and the next time I see you all, I will see you in person on January 2nd. I'm very hopeful of that happening and very excited to get back to class. Today I just want to get us started in section 6.2. We're going to work more in section 6.2. There's quite a bit to it when we get back for a couple of days before we have a little celebration on 6.1 and 6.2 as I have posted. So these notes, which you should have, right, look like this. Well, yours are not color, but like this. They just kind of get us thinking about when we worked in chapter 2 with transformations, what happened when we took each element in just a single list of numbers, univariate data, think of grades in a class, what happened when we added or subtracted something to those grades, right? So it's just getting us to think about that, and then we can make the connection to random variables. And so we know that if we had, let's say we had a transformation, y equals a plus bx, right? So what does the a change, what does the b change, right? So just get us to think about this. You probably remember, right, center, spread, and shape. What changes, right? So adding, subtracting versus multiply, dividing. So what changes the center? Will adding and subtracting change the center? Of course. Right, so changes the center. Right, we're going to add, right, IA. Right. Well, multiplying, of course, change the center. By B. Right, you multiply the center by B. When you look at spread, right, we said that adding and subtracting, that's not going to change the spread. You're just going to shift the distribution left or right, right? So spread is the same here. But we know that multiplication affects the standard deviation because it changes the relationship between values. So let's think of everyone's grade. If I bump up everyone's grade 10%, wouldn't that be nice? Someone with an 80 gets now an 88, but someone with a 70 gets a 77. So it's not kind of a uniform change. And so the spread will change, right? The spread changes by a factor of B, right? And it's going to be the absolute value of B, right? Because it can never be negative. So if B were a negative for some reason. And then the shape. So we're talking about center, spread, and shape. So if you add something, right, it's just going to shift it left and right. The shape stays the same. So if it was skewed, it's still skewed. If it was symmetric, it's still symmetric. And then when we multiply and divide, we made some observations of this. If you recall, we made box plots, and we looked at what happens to the shape when you add and subtract, right? We said just shifts. But when you multiply, there is some, morphing that goes on, some stretch or compression, which you called that in, you called it that in pre-calculus. But still, the shape, in terms of the characteristic of the shape, will stay the same. So a symmetric graph would still be symmetric. Maybe it's just squished or spread out. A skewed graph is still skewed. It may become more grossly skewed one way or another, right? But the shape, the overall shape is the same. Okay, so it's good to reflect on what we talked about in chapter 2 before we kind of go forward in section 6.2. To think about the connections that can be made, okay? So let's take a look at a distribution, of random variables. And in this case, I took this right from the book. I think it's a nice example to go through. I think that it does what it needs to do in the way of explaining the transformations. And so we'll take a look at this, and you'll get some practice using the graphing calculator, all right? I will like to see a setup, and so with the AP board, right? But here we've got this scenario. It's kind of a goofy scenario about a tour company. They have to have 2 passengers to run, and it holds up to 6, right? So this is a discrete random variable. They choose to write it horizontally, doesn't matter. I did it vertically yesterday. All right, these are subscripts. All right, so this is basically a discrete random variable, okay? And they're going to come up with these probabilities, probably from prior research over the year. What's the probability that we only get 2 passengers on any given day? What's the probability that we get 3 passengers, based on data that they've compiled? Okay. So what we're going to do with this is we're going to take this and we're going to essentially see what happens when we do things to the random variable, okay? So the mean of x, right, mu sub x, would be equal to the product of each random variable times its probability. And by the magic of television, I have that answer right here. Okay, so that is 3.75. All right, so what that means is that on any given day, right, we're going to have on average 3.75 passengers for this company. And so obviously we know we can't have a fraction of a person. That would be pretty messy, but we can't round that to 4, right? We have to leave it as 3.75, okay? And then we want to know, on average, how far would each outcome vary from that mean. And so we need the standard deviation. And the standard deviation can be found if we knew the variance. And so to calculate the variance, we would take the mean, right? And we would see how far is each random variable from that mean. So 2 minus 3.75, that's going to be a negative, so we square it. And then remember, we weight it, so we multiply that by its probability. And then we're going to do that for each and every term. 3 minus 3.75 squared times its probability. So this gets kind of long. I have 5 of them, so I'm going to do it out here. But if I had 8 or 10 of them, I would just set up the first few for the reader to see that I understood the process. And then use my graphing calculator. I'm going to use my graphing calculator anyway to do this, but I'm just setting up the work so that they know I understand the process. And plus 6 minus 3.75 squared times probability. Okay. All right, so that standard deviation, variance, I don't have that, I have a standard deviation, is whatever 1.090 squared is. Okay. Then if I take the square root of that, I get the standard deviation, which is 1.090. Okay. All right, so I'm just going to write it out like this once, because certainly you can do this on the upcoming problems, but I do want you to know how to expand it out. You're going to have these formulas on the AP formula sheet, so you're not going to need to memorize those. But remember, you can do this on the TI just by entering in the X values into L1, the probabilities into L2, and using 1-var stats. You put the L1 into the list, and you put the L2 into the frequency. Okay? And so we get the mean and the standard deviation of this distribution. And so now what we need to do is we need to explore and see what happens when we transform that X, right? X is the number of passengers. What happens when we transform it? So what I'd like for us to do is take a look at that, but I want us to use our calculator to do the exploration, so we don't have to do this out every time. So if you look at the next page, right, it said Pete charges $150 per passenger. It's a pretty good deal for Pete. It was a good ride. Okay. Sorry, my board needs to be cleaned here. Okay, so Pete charges $150 per passenger. So if he has 2 passengers, then he's going to get $150 per passenger. And so 150 times X would be what he's getting, right? So we're going to call that C, all right? And so each one of these now is going to change, right? Because now we're going to have 150 times X, so 300, 450, right, 600, 750, and what is that, 900. Okay, I did my arithmetic right. So notice that the probabilities of these outcomes aren't changing. And so if we were to graph this as a histogram with the probabilities on the vertical axis, the shape's not going to change, right? The only thing that is changing would be the horizontal axis. And so obviously when you look at that, you can see that the shape of that distribution is the same, but the center is different. So what is the center? If we look at the old answer, right, what is the center compared to the answer we got for just X, right? What is the center? So what I want you to do is find the mean of C and find the standard deviation of C, okay? And do that on your graphing calculator. All right, pause this right now and do it on your graphing calculator. Enter this into L1, this into L2. Get your answer, right? And now I'm assuming you did it on your graphing calculator. You should have gotten $562.50 with a standard deviation of 163.50. Okay? And so, hopefully, if you compare this to what we had for the last one, right? We had the mean of X was 3.75 and the standard deviation was 1.09. So if you were to multiply this by 150, right, we should get this new mean, and if you were to multiply the standard deviation by 150, you should get the new standard deviation. So is this an aha moment? Not really, because we kind of knew what to expect based off the experience we had in chapter 2. Okay. For the next problem, it says what happens when you add a constant to a random variable. We're going to go off of this, okay, and we're going to say, well, what if based on his TOR value, right, on his payments, right, he gets or he doesn't get, he has to pay $100 in order to buy permits, gas, and the ferry pass, right? What would be the profit? And they're calling the profit V. Okay, so once again, we're creating a new scenario here where he's just taking what he has here, right? And so now V, right, I can either say that V is going to be C minus 100, or V is equal to C, which is 150x minus 100. And what's going to happen to the mean and the standard deviation? Do you think the mean will change? Do you think the standard deviation will change? Well, try it out. Right, so once again, the only thing that we are changing, right, is the x value. So each x value now is being decreased by $100. So we got 200, 350, which I could see. There we go. 500, 650, and 800. Okay. So if you were to do this out again on the graphing calculator, just go into L1, change it up. Right, put this on pause for a second, and find the new mean and standard deviation. Okay. So the mean should be 462.50. The standard deviation is 163.5. And this is now for the new random variable b. So this shouldn't be a surprise, right? The 163.50, that's what we had for the 150x, right? We're just subtracting 100, so that's not changing the standard deviation at all, but it is changing the center, right? The center was 562.5, now it's 462.5. Okay, so this first section really is just kind of, this first part of 6.2 is kind of a review, but it's pulling what we learned in chapter 2 into the setting of a random variable. Okay, so I'd like you to work on the problems in 6.2 A today in class. Probably can do it in class and get it over with. Tomorrow I would like you to do, I just have a quick kind of review of 6.1 I'm going to have you do together, and make sure the homework is finished up in 6.1 A and B and 6.2 A, and pass that in please. So anyway, I hope everyone has a wonderful break, well deserved, and I'll see you in the new year. Happy New Year, everybody.